Hi, I'm Ned Steinberger. This video is intended for luthiers who are interested in headless guitar design. In particular, I'd like to show you the new Fulcrum tuner, my most recent tuner design. It's unique in that the tuning knobs face up. The advantage of that is it gives more freedom of design because it's not necessary to have the body cut away in order to access the tuning knobs that face back. Another thing about this tuner that's very special is that it has self-clamping. So when you want to change a string, you simply loosen the tuning knob, remove the string. The ball ends are at the head. Then to install a new string, you simply insert it into the tuner. There's an opening in the back here to pull the string through, to pull out the excess slack, and then you just tune the string up with the tuning knob, and it's that simple. No tools are required. So now I think the best thing to do would be to switch to my 3D modeling program so that I can show you this tuner in more detail. And so here you get to see the tuner kind of up close, and you see again the up-facing tuning knob. Here's your intonation screw for adjusting the intonation, and moves this center mechanism back and forth. And here you see the action adjustment screw to move the saddle up and down. And this is quite unique. This is a clamp so that when you finish adjusting the tuner and you get the intonation and the action the way you want it, you can clamp it in place so it's just absolutely fixed solid, and is very good for enhanced sustain and brilliance of tone. But maybe if we do a cross section here, we can look inside and see how this thing is actually configured. So here's the string, of course, and it goes down into the tuner, and you can see this is a clamping point here and a clamping point here. This is a patented design. The limitations of the 3D modeling are such that I can only show you roughly how it works. As this is tuned up, this is the position where you would load the string, and the actual mechanism then opens up, and it's easy to slide a string in. And then as you turn this tuning knob here and this tuning arm moves down, you start adding tension to the string, and you could keep going to whatever you need to in order to get it tuned up to pitch. It's that simple, really. Again, this clamping mechanism is actually powered by the tension of the string, which means that as the tension of the string increases, the clamping force increases proportionally. So it just hangs onto that string like crazy. It's an extremely stable system. So again, we've looked at the intonation and action adjustment and so on. So I think we've kind of covered this for now. Let's take a look at how it will install in a guitar. So let me pull up a drawing here that would give you a little bit of an idea how that would work. So here you see a body represented by these blocks, and you could see that the tuner are just installed from the top, and the height is such that you can screw them right down to the top of the body. You don't have to make a route to drop the tuners in, but you do need a route to have the internal part of the tuner give clearance for that. This, of course, is your parallel fret version with a rectangular arrangement for the tuners, and then here you have the tuners slanted for a multi-scale configuration. And in this case, the angle is 22.5 degrees, but it can be any angle that works for the design that is envisioned. It's really pretty straightforward. But maybe we want to take a look at a cross section. So that's how it fits into the body itself with these long screws, and they come with the assembly. They have a lot of gripping power, and the pilot hole can be fairly large so that it doesn't stress the wood out, and that's really the way to go with those long screws. So that's how they install, and there's really not a whole lot more to be said about that. Then what about the other end of the instrument where the ball ends, of course, are at the head? And so let's take a look at some of the options of how to secure the ball ends. And so here we have an example of a headpiece. So it's a single headpiece for all the strings. This one actually is 3D printed. It can be in stainless steel or bronze infused steel. They're very strong, a very secure way to hold the strings. You'll notice there are no screws holding it down that are visible anyway, and that is because it's, I'm going to make this transparent so we can take a look inside here a little bit. you can see here that there are these two flathead screws that are screwed into the end of the neck, and there are slots in the head plate that slide into those screws and hold it down securely. And I think the best thing to do would be for me to bring that part up individually. Let me get rid of this transparency here, and let's take a look at this part separately. Okay, here it is. Here's where the ball ends go, of course, and when you look at the bottom, you see how it's all cut away like that. All the excess material is removed. That's something that is very doable with printing. There are so many possibilities with 3D printing that can really make a difference in the part. The advantage, of course, of cutting all that material away is it lightens this up, and that's a good thing. Keep it light for balance. And here are the slots I was talking about, where those flathead screws slide in, and these are tapered such that as this is pushed into place, the down force of the screws is increased, and it's just held in place very firmly. Another nice thing about making it a 3D printed part is that the string spacing can be pretty easily adjusted so that each print would be suitable for the width of the neck that is being employed. So that is about what we wanted to cover there. So let me back there, and so I'm going to open up another version, what I call a tube anchor. Very simple system. Should be coming right up. And it's just really, in this case, it's a high, engineered plastic that is of very high quality, that is readily available. And looking closer at how it's really installed, let's get another cross section here. So you can see that there's just a hole drilled in the end of the neck, and this tube is inserted, a little extra clearance for the ball end. The ball end could also stick below. This is really optional to have a recess there, but it's kind of nice. And it's very easy to if you get a piece of this rod, this is 3/16 inch diameter. It's easy to drill this hole in the middle of it with a simple drill press. You put the rod into the drill press, set up a drill bit that's the diameter, the interior diameter you're looking for. You put that in a vise on the table of the drill press, and then when you rotate the shaft and you get the tube rotating, and that means that the drill bit actually will self-center and give you a really clean, simple solution that you can do on your own. No need to purchase a finished part or whatever. So this is a really good option that I wanted to share with you. There's a third option that is also kind of interesting, and I can show it here. So it's actually quite similar, except instead of just having a tube going through, you have this anchor part here, which is made of aluminum and is available. And again, the cross section will help us to see how it installs. It's very simply just a hole through the wood, and this anchor part fits in, and then it screws into place with the screw from below. That sums up really what I wanted to share with you. So I guess that pretty much covers it. I appreciate your interest in headless design. Certainly a lifetime interest of my own. So thank you very much for listening. Bye-bye.